In our next section, we're going to discuss the graphs of the sine and cosine function. And before I specifically talk about the sine and cosine function, I want to remind you about the graphs of a general function. For example, if I know what the graph of f of x looks like, you should remember that if I multiply f of x by a constant, that's going to cause a vertical stretch or a vertical shrink. If I add or subtract a number inside the function, that causes a horizontal shift, okay, in the opposite direction. If I add a number outside of the function, that causes a vertical shift. One thing that we didn't do much of in the first semester was that multiply the x by a number inside the function. That's going to cause a horizontal stretch or a horizontal shrink this direction. But it's in the opposite of what you would think about because it's inside the parentheses. So if the b is bigger than 1, it's going to cause a horizontal shrink. If the b is less than, between 0 and 1, it's going to cause a horizontal stretch. Remember that if a was negative, that caused a flip about the x-axis. Well, in this case, if b is negative, that's going to cause a flip across the y-axis. We have our generic equations for any function. The first one says y equals a times f of b times x minus c plus k. Well, I can factor the b out of both terms inside of the parentheses here. If I pull the b out here, I just have x minus c over b. Well, that c over b is what we were calling the h. So if I'm going to end up with some sort of horizontal scaling in my function, the c over b term is what actually is going to give me my h term. These shifts work for any function whatsoever. So that's why the emphasis during first semester was talking about functions, their graphs, their shifts of their graphs. So today we're going to specifically talk about sine and cosine graphs. So the first thing I'm going to do is I'm going to make a rough sketch of the sine and cosine graphs. To make a rough sketch of the sine and cosine graphs, you need to graph. All you need to do is graph the quadrantial angles. So first one I'm going to graph is sine. So we are going to go out to 2 pi. Then we have pi. This would be half of pi. This would be 3 pi halves. This would be negative pi halves and negative pi. We should know from our prior classes and what we've done in the previous couple days that the maximum that sine goes to is 1 and the minimum is negative 1. And the same thing with the cosine function. So I'm just going to label my graphs. Pi, 3 pi halves, and 2 pi. So at negative pi, I'm at 0. Negative pi halves is negative 1. 0. Positive 1. 0. Negative 1. 0. Connect them with a smooth curve. And we're going to put dotted lines here, signifying that this graph continues on in that cycle forever. So for cosine, it is negative 1, 0, 1, 0, negative 1, 0, 1. Okay, please do not connect these dots with straight lines. We do not want it to look like Charlie Brown's sweater. Okay, so we need to curve them. And again, this is going to continue down this way forever. This one's going to continue up. And that's going to continue its cycle. So the first thing we want to talk about are some definitions. So the first definition that I want to talk about is what is a period of one of these graphs. So first thing we want to say is that these are called periodic functions. Sorry, that pen's not working. Get you another one. What? He's black. Periodic functions. And a periodic function repeats at a specified interval. That interval is called the period of the function. So the sine graph, I'm going to label this one as sine of x. This one is cosine of x. The sine graph starts at 0 and goes up. So from 0, I got to find the next place where it gets to 0 going up. And that would be over here. So this distance right here is called the period. Okay? And the period for the sine graph is 2 pi. Same thing here. The period for the cosine graph is 2 pi. The maximum and minimum of both of these graphs for the generic graph are the same. It's +1 and -1. If we go halfway between the maximum and the minimum, in this region right here, that height is called the amplitude. So this height here is the amplitude. So we have the period of the function that we're going to discuss. We're going to have the amplitude of the function. So key things I want to point out here. Sine starts at 0 going up. Cosine starts at 1 going down. If I had a negative sign, it would start at 0 going down. And if I had a negative cosine, it would start at -1 going up. What you should notice is that if I take this sine graph and shift it pi halves to the left, so if I were to take every dot on the sine graph and shift it pi halves to the left, this is the graph I would get, and that is our cosine graph. So sine and cosine are related to each other just by a physical shift. And that shouldn't be too hard for you to realize, because that shift is pi halves. And we know that the cosine of 90 degrees minus an angle is equal to the sine of that angle. Similarly, we know that the sine of 90 degrees, pi halves, minus an angle, is equal to the cosine of the angle. That's why those phase shifts of pi halves are going to get you the graph of the other function. So let's talk about the amplitude of the function really quick. The amplitude is equal to the maximum minus the minimum divided by 2. So my amplitude is 1 minus a minus 1, which is 2. 2 divided by 2 is 1. This is represented by the letter A, and our amplitudes are always positive. So the absolute value of the letter A in our generic sine function, A sine B of x plus C plus K, is our amplitude. That tells us how far up and down it goes from its midpoint. So let's talk about some other things here. So we've taken into account the letter A, the letter K. The K is our vertical shift of the graph. So vertical shift is going to be equal to the letter K. So if I know what my vertical shift is, I'm going to add the amplitude to it, and that's going to give me my maximum. I'm going to subtract the amplitude from it, and that would give me my minimum. The thing I want to talk about is this B. That B is related to the period of my function. The basic period of my function is 2 pi, and if I have any horizontal scaling of my function, it's going to be with that B term. So the period of a function is equal to 2 pi over B. And the last thing I want to talk to you about and warn you about is this term C right here. You need to be careful with that C. Okay, most of you would think that C is the horizontal shift. Well, it's not the horizontal shift until you actually factor a B out. You need the X and the H by itself. So what I'm going to do is I'm going to factor out the B. That would give me the sine of, open parentheses, B times X plus C over B. That C over B, another name for that C over B is negative H, and that is my horizontal. So I have provided you information. So I'm going to give you this piece of paper, which you should be taking your notes on for this. We give you 2 of them. When we actually graph our functions, I have plenty of what we're going to use for trig graphs. Notice that when we graph, we're going to want to graph at more than 1, but read the directions because it'll say graph 2 periods, 1 period, or whatever. Notice that each period has 4 key points in it. So whatever your first thing we're going to want to do when we want to graph one of these functions is we're going to want to find the period so we can figure out how far our scaling is going to go horizontally. The other thing we're going to want to do is we're going to want to find the midpoint of our graph. And our midpoint of our graph is just going to be the letter K. And then we're going to want to figure out what our maximums and minimums are from there. And that is the letter A. And we're going to graph the original function. Okay, using those pieces of information. Once that is graphed, we will then take into account the horizontal shift. And the horizontal shift for a trig graph is called a phase shift. So I'm going to do some example problems for us. And the first one I am going to do is problem number let's do number 47 from page 466.